Okay, so using this substitution, we get that sine x is equal to 2 sine x cosine x, sine x over 2 and cosine x over 2 using the double angle formula. Sine x over 2 is t over this. Cosine x over 2 is 1 over that. So we get this for sine x. Cosine x, we have this. Cosine squared x minus sine squared x, but the angle is x over 2. So cosine x over 2 is this. If you square that, you get this 1 over 1 plus t squared minus sine is this one here. If you subtract it, you get 1 minus t squared over 1 plus t squared. So if you make the substitution, we get this along with, if you differentiate this, you get dt is equal to secant squared x over 2 times by half dx. Secant squared x is equal to exactly 1 plus t squared. So dx is equal to 2 over 1 plus t squared dt. So that would all cross out. If you multiply top and bottom by 1 plus t squared, you're only left with 2 over 6t minus 4 plus t squared. Maybe leave the 2 at the front. So there's a small mistake when I expand it here. There should be a 4 at the front here. So that factors out to the following. 4t minus 1, 2t plus 2. You can reduce that t with, the 2's with this 2 up here to get 4t minus 1, t plus 1. Now we know that we have to integrate this by partial fractions. So a, b, let me expand up here, at plus a plus 4 bt minus b. So factor out t, you get a plus 4b plus a minus b over. So a plus 4b will have to equal to 0, and a minus b will have to equal to 1. Since a is equal to minus 4b, I can plug in minus 4b in here, and you get b is equal to minus 1 over 5. If b is equal to minus 1 over 5, you can see a, plugging it back into here, is 4 over 5. So we can express this is integral of 4 over 5, 4t minus 1, plus or minus 1 over 5, t plus 1. Okay, so let me continue back up here, and we're left with 4 over 5 times by 1 over 4 ln of 4t minus 1 minus 1 over 5 ln of t plus 1 plus constant. So if I just multiply these two, I get this. Finally, t is equal to tangent x over 2. So 4 times tangent x over 2 minus 1 minus 1 over 5 ln of tangent x over 2 plus 1 plus c is the final step to get to the antiderivative.